Okay, let's do number 5 from the 2024 AP Calculus exam, release for response items. We have the curve x squared plus 3y plus 2y squared equals 48. It says it can be shown dy dx is negative 2x over 3 plus 4y. There's a point on the curve near 2, 4 with x coordinate 3. Use the tangent line of the curve at 2, 4 to approximate the y coordinate of this point. Okay, so dy dx at 2, 4 is going to give us negative 2 times 2 over 3 plus 4 times 4 is 16, so negative 4/19. So the tangent line approximation is going to be given by y minus 4 equals negative 4/19. I'm going to double check that in just a second. Over x minus 2 at the point 2, 4, negative 4 over 19. Okay, we're good. That's the tangent line approximation, or the tangent line to approximate. So we're going to approximate when x equals 3. So we're going to say y minus 4 equals negative 4/19 times 3 minus 2. So y equals, this is going to be negative 4/19 times 1 plus 4. And we're going to leave it at that. That's the y coordinate for part A. Here's the horizontal line y equals 1 tangent to the curve. Give a reason for your answer. So that would mean at some point dy dx would have to equal 0 when y is 1. This implies dy dx equals 0 if y equals 1. Because the point something 1 would have to be on the curve at the tangent, point of tangency. So let's look at that and say 0 equals negative 2x over 3 plus 4y, which is going to be 3 plus 4, 7. And therefore, when x equals 0, then dy dx equals 0. Oh, let's see, we need to check. Let's make sure the point 01 is on the curve. Is the point 01 on the curve? That is not on the curve. We would have checked that also. We'll come down here and check that. So if the point 01 is on the curve, then there would be a point. Then y equals 1 would be a tangent line. But 0 squared plus 3 times 1 plus 2 times 1 squared does not equal 48. So 0, 1 is not on the curve. And y equals 1 is not tangent to the curve. Does the curve intersects the positive x-axis at the point square root of 48, 0? Is the line tangent to the curve at this point vertical? Give a reason for your answer. Well, if it is vertical, then the slope would be undefined. So let's see part C. dy dx at the point square root of 48, 0 is going to equal to negative 2 times square root of 48 over 3. That is not undefined. Therefore, tangent along the curve has slope negative 2 square root of 48 over 3, not equal, well, not vertical. Not a vertical line. That's part C. D, time t greater than 0, particle moving along another curve, defined by the equation y cubed plus 2xy equals 24. The instant the particle is at a point 42. The y coordinate of the particle's position is decreasing at a rate of 2 units per second. At that instant, what is the rate of change of the x coordinate of the particle's position with respect to time? So, we're going to take the derivative of this. We're going to get 3y squared dy dt plus 2 times, we're taking the derivative with respect to t, so we're going to do x times dy dt plus y times dx dt. Using implicit differentiation because we're not taking derivative with respect to x, and that equals 0. We know that the dy dt is negative 2, and we're at the point 42, so we plug in and we get 3 times 2 squared, the y coordinate, dy dt times negative 2, plus 2 times, and x is 4, times dy dt is negative 2, plus y is 2, dx dt equals 0. This is 3 times 4 is 12, times negative 2 is negative 24, and this is negative 8 times 2 is negative 16, plus 4 times dx dt. I'm going to double check the arithmetic there. 4, 12, negative 24, 4, negative 2, that's negative 8 times 2 is negative 16. This is negative 40, so it'll end up being 4 dx dt equals 40, dx dt equals 10. So, rate of change, x coordinate, at 4,2 is 10 units per second. And that's problem number 5.